Yes, hack my talk, but deploying Kubernetes. That's what we are now talking about. And I'm also very surprised that most of the people still sitting here because we're talking about Kubernetes, and I always see people like running away from it. And that's why I give this talk, to give you like not like a real overview, but introduce you to some weaknesses Kubernetes have, and we will look at the logic of Kubernetes itself. So to start, I will give you a brief introduction to who I am. My name is Benjamin Koltermann. I'm from Germany. I'm the former CEO of Avolens. We are doing Kubernetes auditing and Kubernetes security for larger companies. I'm also in Kubernetes, or cloud security engineer, as you want to call it, CTF player at FluxFingers. And my Twitter handle is Paketo or Packet Zero. So before I start, actually, thanks to Google Cloud for sponsoring the environment. I want to keep it short. I created a whole Kubernetes environment, and it's a bit pricey, so I just want to say thank you to Google. The whole talk is not about GKE, it's about vanilla Kubernetes. It's very important, and just that you know. So what's on the agenda? For today, we are going to start with Can You Eat It? I will give you a brief introduction about what Kubernetes is. I think Matthias did a really good job on it, so we will keep it short. The next thing we are going to look at is the demo environment, because actually this talk is running in Kubernetes. The slides are in Kubernetes. It's not PowerPoint and stuff like this. It runs inside of Kubernetes. At third, we are going to have like a little 101 of Kubernetes security, just that you learn some security issues that exist in Kubernetes. The fourth topic is we're going to have a look at the advanced scenarios, and at last one, we will do like a little security evaluation of the Kubernetes application itself you're currently seeing here. So let's start. Can you eat it? No, you cannot eat Kubernetes. Kubernetes is like more. It's a word some people don't have heard. So just to starting like with a little joke. What is Kubernetes actually? It's a container orchestrator, and I also wanted to keep it short. It consists of worker and master nodes. So the master is like the controlling component that does the scheduling of your workloads, and the worker nodes actually running all of the workloads. So there's kind of you differentiate between master and worker nodes. Kubernetes also has this concept of everything is an API object. So actually, every pod you run in your Kubernetes is an API object. You can, for example, also curl it if you like authorize to the Kubernetes API. So everything is an API object, and we will see that one later. Also, the most here at Kubernetes, let's say, words or objects you will find are nodes, which are like the VMs the workloads are running on, namespaces, which are like logical separation of your workloads. There are deployments. Deployments consist of pods, deployments consist of pods, so they like kind of define where and how your workload or your pod is going to be run. Then there are services. Services are there to, let's say, exposing pods to other pods or to the internet, and there's ingress, which does like ingress control, as you might have guessed. Also, this is also something I want to keep really short because Matthias did the introduction to it. I just want to say that the Kube API server is like an HTTPS or an HTTP API where users actually talk to the cluster. So I copied for me or for the security folks, most important sentence from the Kubernetes documentation. Just that if you read it, everyone here should think about and should think, oh, I have really to secure this one. And the Kube API servlet is like the primary, let's say, API where you talk to, where you can like control all of your components and all of your API objects. The next one is etcd. Etcd is like database where your whole cluster configuration is stored. Also something where you have a look at and where your security strategy should apply. The next stuff is the kubelet. The kubelet is like the primary node agent, runs on every node, exposes an HTTPS port, and with the kubelet you can like control the pods that are running on the node where the kubelet is running, and that's also why you should definitely have a look at it and also get that one into your security strategy. And the last one is the container runtime. The container runtime itself is just responsible for running your container workloads, but also that one should belong in your container, should belong to your Kubernetes security strategy. So that's it for the brief introduction into Kubernetes. Nothing more. Let's start with kind of the fun things. So let's have a look at the demo environment I created. I thought about doing this talk, and I needed kind of a demo application. So after thinking for like 2 minutes, I was like, hey, let's do my presentation in Kubernetes. And actually, it looks like this. So it's a little application. We have one master node. We have 2 worker nodes. We actually have one namespace that works like in content delivery network, delivers like the JavaScript and the pictures you're currently seeing. And there's another namespace that works, kind of as the static HTML it's currently serving my slides. So there are 2 deployments and 2 different namespaces. And yeah, those are running the presentation you're currently seeing. What we also have to do for this talk is we need to do some assumptions. So the first one is I don't attack the Kubernetes source code itself. It will be just on the Kubernetes logic. So you won't see me doing like, oh, here's like 1 bit in the source code set wrong. You can do buffer overflow there. It is more like those are real Kubernetes features, and we are like abusing real Kubernetes features. We are attacking the logic of Kubernetes. Also, this talk has no interaction with any third-party product. It's only vanilla Kubernetes. You will find anything you see here. You can do anything without third-party products. And the third step is, after a successful exploitation of application, in some scenarios, the hacker gains access to different Kubernetes resources. This is something I had to put in because if you configure Kubernetes like right, it's extremely hard, nearly to impossible, with only attacking the logic of Kubernetes, like to gain code execution in the cluster and stuff like this. So some scenarios, some advanced scenarios you will see are building on that we have hacked, for example, the application, the web front end, and gained, let's say, access to the node or stuff like this. So let's do some math. The 101 of Kubernetes security. It's also, I will keep this one short, and I have prepared lots of demos, so looking forward to those one. First of all, a malicious container image. I think that's you all know what's going to happen if you like have a malicious container image. There are like 2 scenarios. We either pull it directly into the cluster, or some developer builds like a Docker image, a new one, and the first line is basically you choose your base image, and if your base image is the malicious image, then also you have malicious code in your cluster. So takeaway from this one is scan your container images. Please do it. Mostly malicious container images are like the first entry point when malicious code comes into the cluster. Next one is the Kube API server, what we can do there. Kube API server actually gets restricted using RBAC, so please use role-based access if you are creating, for example, service accounts and stuff like this. And also, every pod in your cluster has a service account attached. So if one pod is compromised, the attacker in the pod has valid Kubernetes credentials, and he can talk to the API. And then it's up to you what your role-based access looks like to get the configuration right. Also, please harden your TLS configuration, because if your TLS is like kind of fucked up, everyone could read what your traffic is, and maybe don't do public exposure. It depends if you need it or not. But if you don't expose the Kube API, you're reducing the attack surface massively. So let's go on with the kubelet. And the kubelet is, as I said, the primary node agent, and per default, that's also in the Kubernetes documentation, it allows unauthenticated access to their HTTPS endpoint, which grants control over the node and containers. So normally, per default, it is getting better with time. So what we are currently seeing is if you deploy now a vanilla Kubernetes, it has these configurations set. So in the documentation, it still says it's unauthenticated access, but if you're actually going to create your vanilla Kubernetes cluster, you will see that those argumentations for the kubelet are set. So if you have maybe like an older version, go look at the kubelet flags if anonymous authorization is false or off, because otherwise, yeah, you can just curl your kubelet on /pods and see every pod that's on your node. So please make sure that those configurations are set. And also for the API server, ensure that you have the authorization on and that you're using role-based access and node authorization. We will come to that one later, where this one extremely helps. But just to make sure, those are the arguments you definitely should be setting for the kubelet and for the kube API server. So let's head into container runtime security a bit. Let's start with a container breakout if you don't harden your container runtime. What we're doing here is we run a pod. In this case, it's named breakout. We do an override of the YAML we deployed. For example, we are setting the host PID to true, so our pod can actually use the host process IDs. Our pod actually sees the host process IDs. Thus, we can then later do an NSEnter, which is we're entering the namespace of the first process. We are entering the mount namespace. So we have the root file system of the node literally mount, or we are entering the same namespace as the root file system of the host has, and we have full code execution there. And let me see if I just can pull that one over. Yes. I hope you all can see. Oh, that's I should have mirrored it. And if I'm going to copy this one, and I hope the internet is good enough, and I execute it, you just need to wait a little bit. Yeah, and there it is. We now literally did a container breakout. It's a very, very, very basic thing. And we could only do it because we could use the host PIDs, and we could also start a privileged pod. That's very important. And to show you that we have the container breakout, I will just show you that I can list all containers running on the node. Those are all the containers running on the node. I'm using CTR, which is Docker just for containerd. So we are now on the node, and we are root on the node, so we could do everything there. So the main takeaway of this is, please don't allow privileged pods. It's very important, because otherwise this happens to you, and everyone who could run a pod literally can get root on the node. So let's head into some more advanced scenarios, and those scenarios are, as I said, advanced. So who uses Kubernetes here? Who uses Kubernetes? Maybe in their company. Okay, some of you. And who does Kubernetes security from you here? Okay, also some folks. Nice to hear. So the first advanced scenario is we can create every resource in the cluster, or we just need one specific resource, but let's say we can create resources in the cluster, and we aim to read every newly created secret, even though we are not currently actively accessing the cluster. So what we wanted to do is we want to do data exfiltration on Kubernetes with only the Kubernetes logic, without even touching vulnerable code in Kubernetes. So what we are going to need is we need an admission controller. We need the validating admission webhook in this case. An admission controller, Matthias also did an introduction there. The validating admission controller validates every API requests, and we can then send those API requests that are validated to our server. Actually, this looks a bit like this one. So as a user, you kind of want to deploy your YAML to the API server. But in between, there sits the admission controller and says, is it valid or is it not valid? So in both directions, either it's valid and it's got accepted, and then it's stored in etcd, or if it's not, then it's thrown away, or you get a warning and stuff like this. So I will do the demo at the end of this scenario, so let's head into what does our admission controller looks like. What we can create is we create the validating admission webhook configuration, and we need some operations where it should like get our secrets. We are looking for the create and update operation in no matter what API group and no matter what API version, but we wanted to have the resource secrets here. And also important is notice that it's like sent to my URL. So, and let's demo this one, I think. So I hope everyone can read it. Yeah. So actually, here is like my admission webhook configuration. Looks exactly the same like you see it on the slides. And also, I will show you just to make sure there is that you can see that. Or that you can see that what's running inside the cluster. This is currently running inside the cluster, so just to let you know. So let's apply this one. Now, there it is. So, and now we get it and see if it's there. Okay, there's our secret checker. To actually like receive the secret, I will just open another shell and SSH onto my command and control server, where the secret is going to be sent. So, on the command and control server, there's an Nginx running. So I think you all know what Nginx is and what it does. And I'm just logging the Kubernetes requests that are coming or are sent to the API server, to this Nginx server. I actually think I have to restart it. Start Nginx. And now let's have a look at the log. And on the left side, if you're now going to, let's say, create a secret, that you can see it, we are now creating a secret, a generic secret. I call it demo, and we are using the key as password, and the thing that is like concealed is super secure. And if I'm sending that one, you see I'm getting stuff here. And if we're like searching for the right field, here it's password, it's our key. We see something base 64 encoded. Yeah, so. Let's echo that one into a base 64 and decode it, and you see actually super secure. So what you can do is, we can do data exfiltration in every namespace. This is not regulated or dedicated to one namespace. We can create this admission controller and let it like get all of our secrets or any resource we define, where we define the scope of the admission controller. We can send it to our server, and then we can do whatever we want with it. And yeah, it's like native Kubernetes logic and kind of, let's say, built in. So this is for the first one. Yeah, so let's head into the next scenario. The next one is a little bit, I would say, not that much complex, but it is something you sometimes see at companies that didn't like shift in their head to the new infrastructure model we see today. So what you have like in the good old days, let's say it like this, developers are allowed maybe to debug their code on like dev VMs and stuff like this. And it is possible, and I've seen it a lot, that companies, for example, allow their developers to get a dedicated node just for them, and where they can do, for example, their stuff. They can debug special network purposes there and all of those things. So the scenario is like we are like a developer who somehow gets access to the node, and yeah, what we now can do is we can get ourselves every deployment that is deployed into the cluster, like everything. And we can do it, or we can just do it, let's say, when the deployment uses something special, which I will show you. So we're like in the scenario of stealing deployments from maybe other dev teams. We can do it changing node labels. So the way Kubernetes like schedules workloads is using node labels and node selectors. So what you actually can do is you label your node. For example, you have a Kubernetes node. There is, let's say, a GPU, or it has a GPU in it, and then you label GPU true, your node, that you know, okay, this node has a GPU, and you can then tell your deployment that requires a GPU to run only on that node using a node selector. But we could also abuse this one if we can set node labels. So I can label my dev node GPU true. And with some, let's say, also luck, or if I remove the label from another node, I can get this deployment scheduled on my node. And then I have if I have access to the node, I can have also access to the pod. And then I can access the pod and maybe have a look inside the deployment the other team actually builds. So what we can do is we can label, or I will do the demo at the end again. We can label our node with like a kubectl label. Label the node with the node name key value pair. And in the deployment, it will look like this. I talked about the node selectors. And the node selector we are using now is we are looking at the node selector I'm currently using for my talk. So the node selector I'm using is app slides to deploy slides on I think it was the worker 2 node. I didn't currently have it. But we look at the node selector, app slides, and we will abuse this one to get the deployment scheduled on the right node. Okay, this comes later. So let's head into that one. I don't need the command and control server here. So let me first show you the current labels that are set. There it is. So we can see that the worker 1 has a label called app CDN for content delivery network. And we can see that worker 2 has a label called app slides. If I now have access to, let's say, node 1, and I'm simulating also that one, SSHing on worker 1. So I now have access to that one, giving me sudo rights, just that everything works out as planned. What I normally find on a node is credentials for the kubelet. So everyone who has access to a node has also access to the Kubernetes API. And what I then can do under etc Kubernetes on every node, you will find kubelet conf. And this kubelet conf you can use to talk to the API server. So what I do is I do an export of my kube config and set it to, wait, let me show you it like this, and set it to the kubelet conf. So now that I have a valid Kubernetes config, I can do like kubectl get pods, for example, or like this, and I see every pod, or I see every pods running in the cluster. Now what we want to do, also show the nodes. kubectl get nodes, and show the labels. Typo there. So I can also get the nodes, and I can now also label my nodes. So I do kubectl label. Oh, I don't have the alias here set. kubectl label node worker 1 with app slides. So like this one. And what I have to do, because I can only set one label with the key app, I have to override my current label. So let's do -- override. And my node is labeled. So now if I now do the kubectl get nodes show labels, you will see both of the nodes now have the label slides, and you guess where it's going. If I now, for example, let's simulate that the slide deployment is restarted, oops, okay, get pods. Yeah, I'm in the right namespace. So currently, we will see dash white. You currently see that it's scheduled on worker 2. I can either now, let's say, restart the slide pod, or I will just scale this one for, yeah, just that it works on the first time, because I now have like a 50-50 chance that the deployment is scheduled on the node I control. And if I'm now going to try it, yeah, I just scale it. That makes it a bit easier. Scale slides, replicas, let's say 5. Oh. Huh. So, and if I now do a get pods, you see that there are also pods scheduled on worker 1, these two. And those 2 pods, because I control the node, I have literally full control over. So if I do here ctr-n Kubernetes IO container list. Oh, that's quite big. Let's do it a bit like this one. You can see, for example, over here that there are slides scheduled. So yeah, I could now debug the containers that are scheduled on my node, and I could have a look at it. And yeah, those attacks are normally like seen when you like have larger dev teams that are developing not only one application on one Kubernetes, but like developing together. Those devs, if they have access to the node, those could take over the deployment of the other team, and that's something to consider if you're like, yeah, developing some application with a larger security. Yeah. So let's head into the next one, or more how you can fix those. We have an admission controller in Kubernetes. It's named node restriction, and the node restriction admission controller uses or lets you use specific labels of the form node restriction.kubernetes.io, and no kubelet can modify this label. Let's do a spontaneous demo. I didn't plan to demo this one, but let's do this. No. Oh no, didn't meant to inspect. So if I now do a kubectl label worker1 using this label app cdn. Oh, label. Oh, there's a label node. If I'm going to label this one, and let's have a look over here. If I now do a kubectl get nodes -- show labels, we should see that here is like that the label should be set over here. I don't know. Ah, here is it. Node restriction. Yeah, Kubernetes IO app CDN. This admission controller is also enabled by default now if you deploy vanilla Kubernetes, so you don't have to like edit your kube API and stuff like this. So if I'm now going to do kubectl, kubectl like label node worker1, I copy this label, and let's hope it works because it's really a spontaneous demo. Slides. Yeah, you see, I cannot edit the label. So the admission controller restricts the label editing. Thus, I can now safely deploy my application if I use the node restriction labels in my deployment. So you have kind of to adapt your deployment using the node restriction labels, and that's like the key takeaway here. It's forbidden. It's not allowed to modify labels. But good try. Yeah, you see, it's forbidden. So yeah, I cannot overwrite the label in this form. So it's not quite complex to use those labels, but it can give you like good security if you use them. Yeah, and now let's head into the last one. And the last one is kind of a post-application exploitation technique, where if we like successfully exploited code that runs in Kubernetes, like this talk, and we have really deep access on the node, root access, wouldn't it be a great thing to create like our auto-scaling malware within Kubernetes out of scope for every application, out of scope for every Kubernetes security product out there? I think it is, so let's do it. Who here that also does Kubernetes security is aware of pause containers? Oh, you know them, that's great. So let's build our auto-scaling malware in Kubernetes, and we are going to abuse pause containers. What is the pause container? For those of you who have never heard it, the pause container is like, it's a container that is in every pod, running in every pod, under the radar of the Kubernetes API. It, for example, holds the network namespace open in case a container restarts, that if your container restarts, it gets assigned the same IP address. That's because the pause container is there. And it's also responsible for reaping zombie processes, so that there are no zombies running inside of your Kubernetes cluster. So let's abuse this one. This is like kind of a little step-to-step guide how you can do it if you like get in the post-exploitation phase and successfully exploited a Kubernetes application and have deep access on the node. So first of all, determine which container runtime is used. So we just need to make sure that we know which runtime is used. In our case, it's containerd running. You can have a look at it, for example, if you give me a second. If we do like kubectl get nodes -await, there you see that we are currently using containerd as container runtime. Or you just go and have a look on the node itself, and you see from the tools or from the directories created, or from the processes, which container runtime is used. Second step is find out how this container runtime uses sandbox or pause containers. It's a little bit different from runtime to runtime. For containerd, it's like we are just setting one parameter. For cryo, as an example, you have to set not only one, I think there are 3 parameters to set, but you can read about it in the documentation of the container runtime. The third step is, let's build our own pause container. We have to fulfill some requirements, but we also could use like the official pause.c file and then put a little like shell command in front of it. You will see it later because I actually built my own pause container. And what we should also do is either place the pause container image on the node or put it in like a publicly accessed registry that doesn't require authentication. And the fifth thing is reload the container runtime to use the newly created pause container. So let's demo also this one. So I have here root access on the worker node. And I said we have the containerd runtime. So in etc containerd, you will find config files. I can do it a bit better. I hope you can all see it. And let's have a look at the current config toml. This is a config I set. Normally there is no config toml, but this is also the default pause image for Kubernetes. It's called k8s gcrio. And if we do like the CTR listing, we can also see that there are pause containers running, and they're running several of them. So it's running in like every pod. And now I built my own pause container. Yeah, it's this image, so I just copy it over. Config toml back to config toml. Let's have a short look at it. Yeah, there's running my pause container. What does my pause container do? I also show you that one. Oops. So it is. I will give you the Docker file. It's just like a standard Ubuntu image. I copy the official pause.c from the Kubernetes repo over in this container. And my command is I just curl my demo server here to like show you that it works and that you can create your own like malicious requests out of scope for Kubernetes, and then I run the pause binary. So it's like just to show you, or just to give you like a little demo. Yeah, so we have copied the config over. We just restart the container runtime. And now, if we create a new pod, let's call this deployment lol. Yeah, it's just a demo, so I think it's fine. Let's create a new deployment. Oh, wait, before I actually create the deployment, let me head over to my command and control server. Because actually we can see those requests. So also Nginx is like logging those. Log Nginx. Nah. So, and let's do tail -f on the access log. Oh, no, not tail, please. So we are now seeing the access log. And if I'm going to create a deployment, the deployment must be, in order to get it work, the deployment must be scheduled on the right node. Yeah? So if I'm now going to create a deployment, maybe we have luck. No, we don't. If we like do a get pods, oh, not white, only get pods, we see that the lol container is created. But let's scale this deployment and get some containers scheduled on our node. Like scale, deploy. And let's do like 25 replicas. And we wait a bit, and there's coming the requests. So what we are now seeing is that the pause container actually curls. My server reaches out to it, and if we have a look at the normal Kubernetes environment, it looks like nothing happened. Everything is running, everything is up, everything works as expected. You won't even notice it if you like scanning it with your like commercial container scanning tool, because it's a runtime feature. So it doesn't even, or not the Kubernetes API itself, like gives the request to pull the image. It's the container runtime. So it's out of scope for the commercial scanner you deployed in your Kubernetes cluster. And I can run like literally a malicious image that isn't scanned in every pod and auto scales. It's a great thing, I guess, for me as an attacker. So yeah, the curl requests getting in, and let's see what the best things about those are. Yeah, in every new instance or pod created, depends on if I could, for example, set my config.toml on like a scaling template for Kubernetes, for a VM scaling template. Every new created node has my pause container on it, so I can infect more and more nodes. Every new instance or every new pod created on the node is, yeah, I can abuse to do my malicious code execution. It is out of scope for every common Kubernetes security tooling, included, as I said, your commercial or paid tooling you're using. The Kubernetes cluster behaves normal. You won't see any difference. You won't even like notice that things changing there. And it persists over reboot and over update in your whole Kubernetes cluster. So it's a very evil thing to identify. It's actually very horrible to do this. Yeah, and what I can do from this, for example, if we come back to like attacking the Talk infrastructure itself, if I should have done it, or if I had done it before I actually deployed my real Talk environment, I would have a container in every pod and in every, like let's say also namespace, yeah, not the namespace in Kubernetes, but the namespace that containerd uses, so Linux namespaces. I had the pod in every Linux namespace where I can like reach out to the official workload pod and do stuff there. So it's very great that you can actually do stuff with this. Yeah, the next one is, over the years, I stumbled over several different security, Kubernetes security-related topics, and we always, for example, when I worked at the customer or somewhere else, we always had like some issues to do like threat-based analysis for Kubernetes at a larger scale for like really big clusters with hundreds and thousands of nodes and stuff like this. So over the time, I like collected all of those threats in Kubernetes I've seen, and I kind of built my own MyTree attack metrics for it. And this is also the stuff that is going to be released with the talk, together with an open source Kubernetes security blog hosted on Kubernetes Security DE and Kubernetes Security IO. Those are both domains. We will be using to get you folks informed about Kubernetes security and what's going on. So this is what it looks like. It's a big metrics, and I'm extremely sure that there's still stuff missing. So if you actually have some more attack vectors that you would like to see or would like to share with me, I would like to put it in there, because also from my perspective, Kubernetes is such a big ecosystem, and getting the overview about every potential, let's say, vulnerability we have in there it's totally crazy. So please reach out to me if you like have other newer, different attack vectors or think that there's something missing. Please reach out to me. I will definitely put it in, and the metric is also to be submitted to the MyTree team. Because I think what we should do more is like threat-based Kubernetes analysis to not only get the application security layer right, like securing your web front end and stuff like this, but with Kubernetes we are also introducing platform security. So if your application is hacked, then your platform is going to be under attack. But if your Kubernetes platform is attacked, then your application is going to be under attack. So we kind of have to rethink what we are doing. We need to like secure both layers, not only the application, but also please the platform itself. Yeah, that was Hack My Talk. The whole talk is going to be open sourced. You will find everything on GitHub in this repo. Currently, I didn't finish it in time to like publish everything there, so it's still an empty repo. But I will upload everything there once I've get the materials together. And also, if you want to rewatch the talk, you can actually do it. The talk is running in Kubernetes and was the whole time publicly available. You can have a look at it at the domain you're currently seeing there. It is exposed in the internet, and you can look at it all the time for the whole Troopers conference. It will be up. So that being said, please stay safe, not only in your Kubernetes and application environments, but also in terms of Corona. Thank you.